This is MSJ Chem. In this video, I'll be looking at spontaneity. In chemistry, the word spontaneous has a specific meaning. A spontaneous process is a process that occurs without adding energy, other than the energy required to overcome the energy barrier. From our everyday experience, we know that a ball will roll downhill. That is a spontaneous process. We also know that a ball will not roll uphill unless we put in work to make it happen. Therefore, a ball rolling uphill is a non-spontaneous process. Spontaneous processes can be either fast or slow. On the left, we have the combustion of gas in a Bunsen burner. Combustion is a fast, spontaneous process. On the right, we have the rusting of iron. Rusting is a slow, spontaneous process. So even though we can classify a reaction as being spontaneous or non-spontaneous, it tells us nothing about how fast the reaction happens. The second law of thermodynamics tells us that for a spontaneous process, the total change in entropy, which is equal to the change in entropy of the system, plus the change in entropy of the surroundings, must be greater than zero. So for a spontaneous process, the total change in entropy must be greater than zero. It must be positive. Next, we'll calculate the total change in entropy for a process and determine if it's spontaneous or non-spontaneous. We'll use the top equation, which is the total change in entropy is equal to the change in entropy of the system plus the change in entropy of the surroundings. And the change in entropy of the surroundings is equal to the negative enthalpy change of the system divided by the temperature at which the change occurs. This relationship allows us to make a prediction about the entropy of the surroundings of a process. The total entropy change can then be used to predict whether or not a process is spontaneous or non-spontaneous. So let's calculate the total entropy change for this process in which H2O as a liquid forms H2O as a solid, which is freezing. The change in entropy of the system for this process is negative 22.0 joules per Kelvin mole, and the change in enthalpy of the system is negative 6.01 kilojoules per mole. So let's calculate the total change in entropy for this process at minus 10 degrees C, which is 263 Kelvin. So we use the first equation to calculate the entropy change for the surroundings. Here we have the change in enthalpy in joules, and here we have the temperature in Kelvin. That gives us a value of positive 22.9 joules per Kelvin mole. Next, we'll use this equation to calculate the total change in entropy. So we input the value for the change in entropy of the system and the change in entropy of the surroundings. That gives us a value for the total change in entropy of positive 0.9 joules per Kelvin mole. Because the total change in entropy is positive, that tells us it's a spontaneous process at 263 Kelvin. Next, we'll calculate the total entropy change for the same process, but this time occurring at 10 degrees C, which is 283 Kelvin. Just like the previous example, we first calculate the change in entropy of the surroundings, and that gives us a value of positive 21.2 joules per Kelvin mole. Then we use this equation to calculate the total change in entropy. So we input the values for the change in entropy of the system and the change in entropy of the surroundings. And that gives us a value for the total change in entropy of negative 0.8 joules per Kelvin mole. Because the total change in entropy is negative, this is a non-spontaneous process at 283 Kelvin. So this explains why water does not freeze at 10 degrees C or 283 Kelvin. So to summarize, we can use this equation to determine whether a process will be spontaneous or non-spontaneous. And according to the second law of thermodynamics, for a spontaneous process, the total change in entropy must be greater than zero.